Here's our second example of a problem that involves calculating the dosage of the drug based upon the patient's body surface area. The order reads as follows. Delaverdine, or Delaverdine, however you pronounce that. They should give a class on pronunciations of these drugs. Delaverdine, 220 milligrams per square meter. So 220 milligrams per square meter. Anytime you see that square meter, that meter squared, the M with the exponent of 2, that tells you body surface area is involved in the problem. So the drug, Delaverdine, is to be administered at 220 milligrams per square meter. How many tablets of this antiviral drug, all right, so that's what we want to know, how many tablets of this antiviral drug will you administer if each tablet contains 400 milligrams? So one tablet equals 400 milligrams of the drug. The patient is 6 feet 3 inches tall, okay, and weighs 150 pounds. Use the formula to approximate body surface area. All right, so find your sheet that you printed out that gives you the formulas for body surface area. And you'll notice the two formulas. One of them is used when the information we have is in metric units, and one is used when the information we have is in household units. And the information that we need the patient's weight and the patient's height. So we have the patient's weight in pounds. We have the patient's height in feet and inches. Those would be household units, wouldn't they? So we need to use the second formula that's there, BSA, body surface area for household units. But notice we have to have the height in inches. So we have to convert 6 feet 3 inches to inches. Well, 12 inches is 1 foot. 6 of those would be 72, wouldn't it? And 3 more would be 75. So this patient is 75 inches tall. And so here's how we use the formula. We take their weight in pounds, which is 150 in this instance, times their height in inches, which we've determined to be 75, divided by 3,131, and then we take the square root. Remember, that's what that symbol means. It's not a division sign, it's the square root sign, which we have on our calculator, I hope. Yes, we do. So we need to do this arithmetic to determine the body surface area of this patient. That's our starting point. So we take our calculator, we take 150, the patient's weight, times 75, the patient's height in inches, divide that by 3,131, and then take the square root of that. And the square root of that is 1.8955, and so on. Body surface area is used approximated to the nearest hundredth. So that would give us, in this case, a body surface area of 1.90. So after that calculation, the body surface area for our patient is 1.90 square meters. So that's where I start. The patient has a body surface area of 1 91/100 square meters. Now I put in my rate of administration of the drug. For every square meter of body surface area, the patient is to get 220 milligrams of the drug. So my square meters now cancel. And if I just did this arithmetic right here, I would know how many milligrams totally of the drug the patient should receive. But I want to know how many tablets, so now I have to use my equivalents from the label. 400 milligrams are in each tablet. So one tablet contains 400 milligrams. So my milligrams will cancel, leaving me the number of tablets the patient should receive. So now I can do my arithmetic with my calculator. 1.9 times 220. That gives us 418, and divide that quantity by 400 equals 1.045. Well, again, you can't administer 45 thousandths of a tablet. So we drop that, and this patient would receive 1 tablet in order to make sure they were getting the correct dosage of drug for their body surface area. So in this instance, we used the formula to find body surface area. That formula involves taking the square root, and to use that formula, we have to know the patient's weight in pounds and the patient's height in inches. There's also a formula we can use if we know that information in the metric system, and that's given for you also on that piece of paper that you've downloaded. So here's an example of, again, calculating the dosage based upon body surface area, where first we had to calculate the body surface area of our patient.